Hello folks, welcome back to the engine history. Any real mechanic standing next to this power block will feel the pressure pulses hammering straight into the ground. This is not the high RPM shriek of a jet turbine. This is the sharp, squared-off exhaust beat of a one-piece cast iron monster that rolled out of the factory in 1936. Fairbanks Morse Model 32D, rated at 300 horsepower. 4 massive inline cylinders standing tall, carrying the revs like pillars. This chunk of iron was the prime mover core for power stations and pump stations, grinding under load to build America's heavy industry. Take a hard look at the rocker gear and the crankcase. Today, the crew is going to tear into the compression and combustion specs of this nearly century-old mechanical block right on the test stand. The Fairbanks Morse Model 32D throws complexity in the trash. Engineers cast it with a brutally stripped-down layout. A 2-stroke diesel that deletes the entire intake and exhaust valve train on the cylinder head. The whole scavenging and exhaust cycle is controlled directly through intake and exhaust ports cut into the cylinder wall itself. The piston sliding up and down is what opens and closes those ports. This stripped-to-the-bone structure completely removes the risk of bent valves meeting the piston crown. Keep the oil right. Bleed the air clean out of the oil lines, and this block will chew through decades, crushing load limits without needing a single electronic circuit board. Before we dive deeper into the priming mechanism and the connecting rod system, if you love the bite of burnt oil and the pressure vibration of heavy steel, hit subscribe to the engine history. The support from you is the ammo that lets the crew hunt down and drag home the hardest load engine blocks for teardown. The start problem on this block does not use an electric starter motor. The mechanic has to open a valve and dump high-pressure compressed air straight into the combustion chamber to shove the piston through its first expansion stroke. That air force kicks the solid cast flywheel, weighing tons, into motion. It builds savage rotational inertia, strong enough to pull the crankshaft through top dead center on the compression stroke. The 32D configuration locks its speed in the extremely low RPM band, around 250 to 360 revolutions per minute. But the torque twisting into the crankshaft can snap a load chain clean. That choppy, hard-edged exhaust beat slamming into your ears is the real measurement of how perfectly sealed the early semi-diesel mechanical injector system still is. A mechanic who sticks his head into the engine bay will catch the signature burnt stench of pressure and heat cooking metal. That is diesel exhaust residue mixed with the sharp, face-stinging smell of lubricating oil vaporizing over loaded bearing shells. On a machine like this, the oil film is life or death against a wiped crank. Watch the thick oil being rammed under pressure along the polished connecting rods, flooding the oil funnels and pushing into every bronze bearing clearance. The heat rolling off the crankcase walls measures the combustion chamber's thermal expansion in real time. It turns the test stand area into a mechanical furnace. Every streak of oil sweating out at the crankcase gasket seams is proof that lubrication pressure is being driven hard. It's a violent display of material fatigue resistance from the cast steel metallurgy era. Look at the flaking paint and the scratched, dulled bolt lugs, and anyone in the trade will read real-world mechanical wear data immediately. This 32D spent its whole life chewing dirty diesel and dumping thick black smoke to keep generator dynamos spinning non-stop. The heavy, soot-packed exhaust blasting out of the stack carries the evidence of full combat load operation, pinned to the wall. Stand close to the cylinder block, and the connecting rod vibration punching the air confirms the quality of cast iron and forged steel, built under hammer and workshop discipline. This core mechanical layout leaves one conclusion. Modern electronics can hold RPMs more tightly, but when it comes to brutal load endurance that crushes material without mercy, one-piece cast Fairbanks Morse iron still stands in a class of its own. This live test of the Fairbanks Morse Model 32D on the stand locks in the numbers of just how savage old-era compression and combustion casting can be. Thank you for crawling into the engine bay with the engine history, covered in metal dust and burnt oil, to measure this machine. From a teardown mechanic's point of view, what do you rate highest here? The low RPM exhaust beat, the flywheel inertia torque twist, or the early mechanical injector system? Drop your verdict in the comments so the crew can break it down together. Goodbye, folks, and see you again in the next welding and tuning session.